Welcome to This Explainer. Today, we're going to unpack something that literally every single one of us has experienced. I want you to think about the last time you tried to learn a completely new skill. Maybe you picked up a guitar, tried to learn how to code, or, started studying a new language. At first, you have this massive burst of excitement. You sit down, you're ready to conquer the world, but eventually, and inevitably, you hit a wall. Progress stalls, the frustration sets in. It's a totally universal struggle, but the good news? There is a fascinating science behind exactly why this happens.
It's the ultimate question, isn't it? Why does getting better at something sometimes feel like you're just spinning your wheels and going absolutely nowhere? Honestly, it's incredibly validating to know that this frustration is actually a documented, scientific part of the process. Today, we're going to use something called the learning curve as our diagnostic tool to map out your own personal hero's journey of mastery. We'll look at the data, the psychology behind how we acquire new skills, and figure out exactly where you are on your path to expertise.
Section 1. Decoding the learning curve. Let's look at understanding progress.
Okay, let's dive into this. At its core, a learning curve is simply a graphical representation of your progress through practice. Think of it as a mirror reflecting your efforts. It shows exactly what your practice yields over time by measuring your performance at various, distinct stages along the way.
The math here is actually pretty straightforward. Our x-axis tracks your invested time, while the y-axis maps the amount of learning you've achieved. The continuous interaction between your time and your results creates the shapes that define our entire learning experience.
Section 2. 4 Shapes of Progress. It's time to look at expectations versus reality.
First up, we've got what I like to call the straight line myth. When we start learning something, we implicitly expect a perfectly uniform rate of progress going straight upwards. But that perfect straight line is a myth. It's about as real as a unicorn. So if you aren't improving at a perfectly steady, unbroken rate, don't worry, you are completely normal.
Now, what's really interesting here is how the difficulty of a task radically shapes our early experiences. First, let's look at the convex curve, which is negatively accelerated. This is where you see a huge, fast rate of gain right at the beginning, which then gradually slows down. We usually see this when the task is pretty simple, or if you already have previous practice on a similar task. On the flip side, we have the concave curve, which is positively accelerated. Here, progress starts incredibly slow, but then it increases and speeds up. This happens when the task is super difficult, or when you have absolutely zero previous practice with anything remotely similar.
And that brings us to the most common reality we actually face, the mixed curve, or the S-shaped curve. This is essentially a concave and convex curve smashed together. In most real-world learning, your progress begins slowly as you're just struggling with the basics. Then boom, it rises rapidly as things click into place. But eventually, that rapid rise falls slowly again as you get closer to mastery. This S-shape is the holistic, realistic journey of learning we typically experience.
Section 3. Surviving the learning plateau. Here's how we go about surviving the stall.
So in all learning, those exciting initial gains and rapid progress are eventually followed by a period where the rate slows down so much that it appears absolutely no advancement is being made, even though you're still putting in the practice. This creates a plateau. It's a stationary stage where no measurable progress is recorded. Visually, the learning curve takes the form of a horizontal stretch, literally a line segment perfectly parallel to the x-axis. You're moving right along the timeline of practice, sure, but you aren't moving up on the axis of learning.
Section 4. Diagnosing why we get stuck. Let's start diagnosing these plateaus, because remember, a plateau isn't a failure, it's a symptom. And to get past it, we need to diagnose exactly why our progress has flattened out. Let's break down the precise causes. The first category of causes revolves around your physical and environmental limits. Honestly, sometimes your climb halts simply because of poor physical conditions or mental fatigue. If you're exhausted or you're dealing with an illness, your brain just cannot process new information efficiently. Likewise, a really unfavorable environment or a constant distraction of attention will instantly flatten your curve. Your brain simply doesn't have the bandwidth to push higher.
Next up, we've got to look at motivation and task factors. A lack of interest or an absence of motivation are massive culprits here. If you don't care, you don't climb. But the task itself can also cause a plateau. The sheer complexity of a task can stall you out, or maybe you're giving undue attention to just one specific little part of the task while completely neglecting the whole. And then there's a sneaky one, satisfaction with moderate achievement. Sometimes we plateau simply because we get good enough and we unconsciously stop pushing for greatness.
Finally, we have strategic and habitual conflicts. A faulty method of work will definitely stall you, But this next point brilliantly illustrates a hidden truth. Sometimes a plateau happens exactly because you are transitioning from a lower to a higher level of performance. Think of a tennis player who has to completely change their grip to improve their backhand. Their progress temporarily drops before it spikes. When you pick up a new, better method of work in place of an old one, or when your old study habits conflict with new ones, your visible progress stops. You aren't failing, you are literally rewiring your entire approach, and that internal construction just takes a little time before it shows up on the graph.
Section 5. Spurts. The messy reality of mastery.
So, once you diagnose and push through that plateau, what actually happens next? Well, when you zoom in on a learning curve, you'll see various ups and downs recorded, even during a period where a general acceleration is clearly happening. These day-to-day micro-fluctuations are known as spurts. Even when you were generally getting much better over the course of a month, your daily progress is bumpy. These spurts are caused by all the changing daily factors we just talked about: shifting levels of fatigue, minor illnesses, or daily changes in interest and motivation. It is perfectly 100% natural for progress to be erratic on a micro level.
So the absolutely crucial point here is understanding the clear distinction between these two concepts. A plateau is a horizontal stretch. It's a period of absolutely no progression, just a dead stop on the vertical axis. A spurt, however, represents the continuous ups and downs in your progress while you are actively climbing. Knowing the difference really keeps you sane. A bad day is just a downward spurt in an upward trend, but a whole month of no progress, that's a plateau that requires a new strategy.
Which leads us with this final question to ask ourselves as we look at our own personal journeys toward mastery. Think about that skill you're struggling with right now. Look at your own personal graph. Are you truly stuck in a stationary plateau that requires diagnosing, or are you just experiencing the natural, bumpy, downward spurt right before your next major breakthrough? Keep pushing, keep evaluating your methods, and remember that every single shape on that curve is just another step toward mastery. Thank you so much for joining me for this explainer, and I hope you feel energized to tackle whatever you're learning next.